Okay, let's get started. Welcome everybody to Obsolete DBA best practices. So I'm sure you've seen sessions on all the cool latest and greatest stuff you can do. I'm going to show you all the obsolete stuff. So, first, who are we? So we're White Star Software. We're the oldest and most respected independent DBA consulting firm in the world. We have 5 of the world's top most senior DBAs, and we're also the authors of ProTop. So just a few words about me. I'm the junior of the senior team with only 19 years experience. So I've performed specialized DBA-related services at more than 70. This slide is obsolete. Mostly database administration stuff, installation, upgrades, health checks, performance tuning, etc. Anything around the OpenEdge database, pretty much have done. So why obsolete best practices? So why do I want to show you stuff you shouldn't do? So I want to help you improve performance. So I want to get you to use these new best practices, or newer best practices, I should say. Also help you save time with your DBA tasks, and reduce downtime wherever possible. So this is our agenda. This is what we're going to look at. We'll look at truncating the BI, using version 8, version 9 database structure, AI management, replication, the 2 gig limit, etc. So before we start, just keep in mind, so whatever we're going to discuss here probably applies to most of you, probably 90% plus. In certain cases, what I'm going to describe may not make sense, or may still be a valid practice. It's always a good idea to verify with an expert. And also the recommendations are from version 10 and above. I haven't included any version 12 yet, so maybe in the next version of this obsolete, when this presentation becomes obsolete, pretty much. Is anyone using version anything less than version 10? Okay, good. Everybody's on 10. Anyone on 12? All right, everyone's on 10 or 11. Great. So you guys are the right people. Okay. Okay, that's fine. On the way, and they don't matter. So which one of these items are obsolete? So rotary phone, Progress version 1, Wikipedia version 0, VHS, film. Okay, so all these are obsolete, right? But we could still use them. The question is, should we use them? Rotary phone, maybe not. VHS, I still have a few VHS somewhere, my parents, that I haven't seen in 5-10 years. The Britannica set, I've put them into good use. My son had a cold, so I raised his crib a little bit, and we needed something steady to help prop it up, so they came in use for that. So is your Progress version obsolete? So Progress has this nice product lifecycle guide on their website, and basically it's kind of like a roadmap of where we're at with a particular version, and whether they plan on or when they plan on making it mature or retired, or if it's already retired and we should be moving away from it. So an active version, so active means it's fully supported. When you're upgrading, this is the version you want to be heading to. It gets all the latest enhancements, all the features, service packs, etc. Very similar with the mature, except in a mature environment, it won't include certification for new hardware systems. Retired version, so this is where you want to be upgrading away from the version 9 for those customers that matter. It's not available for sale, only for adding new users to your license count. There's no service packs, nor hot fixes. I mean, Progress will try to work with you, but there's basically no guarantees at this point for the retired life cycle. And one other thing that's not mentioned here, so Progress often issues new service packs. So generally, the previous service pack is considered retired. So for example, if you're using, I don't know, 11.7.3, then it's a retired version. So obsolete best practice number 1, regularly truncating the BI. So I mean, truncating the BI is not necessarily a bad thing, but doing it regularly as part of your best practice is not a good thing. So basically what I mean by that is pro-util your database name -c truncate BI. So some common reasons for this, saving the disk space or backup space, avoiding an uncontrollable size, which is not true, prevent data loss, also not true, but these are some rumors, if you want to call them, that I've heard, or reasons of justifying regularly truncating and monitoring the BI growth. So just to give you a bit of a background on what the BI file is. So every transaction is logged in the BI file. And why we need the BI is to ensure database integrity. So if that session crashes or the database crashes, Progress will go through that BI file and undo or reverse any uncommitted transactions. So basically we'll restore it back to a working state. So a good thing about the BI file and why we don't want to truncate it is because the space is reused. So whatever space isn't used anymore, it'll eventually get reused. And the database BI consists of clusters, and the default is about half a meg. And so basically every time the BI file grows, especially if it grows at something as small as half a meg, everything freezes until it finishes growing. So picture adding rooms to an unfinished building. You're not going to add your rooms and your furniture unless your building is fixed. So this is what needs to happen every time your BI has to grow. So the solution, avoid truncating the BI. And if you do have to truncate your BI, make sure you grow it back to its quote-unquote natural size. So what the natural size is, so every database environment has this natural size, this regular size for your BI. So in one environment it could be half a gig, and another environment could be 2 gigs, whatever the size in the normal day-to-day operations, because it reuses itself. So if your natural size is 500 meg, it'll usually never go over that. It'll get reused, and you'll always remain within that 500 meg. So that's the size you want to stick to. So keeping track of the growth, you could also look at the VST file or the BI file itself. If you happen to be using a variable extent, you could look at the BI file size and see what the size is. Or what's even more useful is look at how much of the BI file is being used. So rather than looking at the size, finding out how much of it is used. So maybe your BI file, for whatever reason, grew to 2 gigs or 4 gigs or whatever. You care mostly about how much of it is being used. And so in Protop, you could actually, in the free version, you could actually see what your BI file usage is. And the premium version, you can get alerted at various thresholds. So there are valid reasons for truncating. So you may want to reduce the size after an unusual operation, like a dump and load, or you finished archiving and deleting a whole bunch of records, and your normally sized BI file of 500 megs grew to 3 gigs or whatever. So it's not a bad thing to go and truncate it, but it's not dire. It doesn't have to be done right away. It could be done during the next maintenance window. Or if there's been a larger scope transaction or a long transaction that's caused the BI to grow. So then it would be a good idea to truncate, but to grow it back to the natural size. If you're connecting to a database in read-only mode, though, then unless you truncate, you always get this warning message before. Warning before image file is not truncated. So in that case, you want to truncate it. So other valid reasons, sometimes certain progress operations will truncate it automatically, like when you're enabling after imaging, or when you're changing the block size or the cluster size. And that's fine. Just remember to grow it back to its natural size, to pre-grow it. All right, obsolete practice number 2. So using a database of version 8 structure in your version 10 or version 11. So what I mean by this is basically storing stuff in the schema area or using type 1 storage areas. So storage area, in brief, it's basically where we define where to store our database objects, where to put our tables, our indexes, and stuff like that. It allows us to place them in specific physical database files. It's also where we can define how many records per block can exist in that storage area, or how many blocks per cluster. And we do that to better tune the database, to retrieve more records with less reads. So there's 3 types of storage areas. So basically type 1 or type 2. Type 0 is basically type 1. And you always want to be on type 2 storage areas. So going back to the schema area, so the schema area contains the master block and other database info. It's very limited. You can't change the records per block, and it's always a type 1 storage area. So you never want to store anything in there. I see it often with side database or custom databases. So it's a good idea to get in there, especially if you're planning your next migration, get in there and reorganize it to a type 2 storage area. And you also can't physically segregate any objects, so you can't put any common objects together or separate your indexes or your tables and stuff like that. With type 2 storage areas, so it's something that's defined when you create the database or the area. So in your structure file, your .st file, basically anything. So here we have our storage area type, storage area name, storage number, records per block, and blocks per cluster. So if this is anything but 1, it's a type 2 storage area. If it's 1, it's a type 1 storage area. So in type 2, all the blocks are grouped together in clusters. And this helps reduce scatter because all the blocks are contiguous. So if you look at this example here, if I have a transaction area and everything is stored in a type 1 storage area. So I have some stuff in ABS master, SPT det, etc. So when I want to read stuff from ABS master, from the blue one over here, I'm reading some of this, some of SCH master. I'm reading objects that don't belong in my query. So this makes the reading time. It takes longer to read the records that you want, basically. In type 2 storage areas, everything is nicely separated. So ABS master grows in its own place, WD det in its own. So everything grows in its own area. So when I'm querying ABS master, I'm only querying ABS master blocks and no blocks from any other records. Obsolete best practice 3. using scripts for managing your after image files. So after imaging is essential for recovering your database. If without after imaging, if you need to restore from last night's backup, and this happens to happen in the middle of the day, you'll lose everything from last night until the point of failure. So we use after imaging to roll forward back all the way to our point of failure. Up until version 10.1, after imaging was a bit of a challenge. You had to write complex scripting. You had to spend more time managing it. And the reason for the scripting, we wanted to avoid an AI stall or a database crash. And we wanted to prepare against failure so we can recover from the failures. So we had to manage the AI files. We needed to archive the full extents, assign descriptive names, and pair them with our database backups. So the solution past 10.1a is use the AI management utility, also known as the AI archiver. So this pretty much replaces most of your scripting. So it's going to archive the AI extents for you as soon as they become full. So rather than having your script wake up every few minutes, the AI archiver identifies them and archives them right away. And it also assigns a very descriptive name. It's probably the only downside. What it won't do, though, it won't compress them. So if you want to compress them, if you need to compress them, you'll have to still script something for that. So it's very easy to enable. rfutil, your database name, AI archiver enable, and then add some startup parameters to your database startup script. So your AI archive directory, and it's always a good idea to add a backup archive directory in case something happens to your main archive directory if it's full or not accessible. Your AI archive interval, how often do you want your AIs to switch? And it's also possible to do it online. So you don't necessarily have to bring your database down. So obsolete practice number 4, using after image files for replication, or what I like to call poor man's replication. So this is kind of controversial because many still use this. I've had a customer recently ask me to do this, but for the most part, there are better ways to do this. So what after image file replication is basically, so it uses your after image files and using scripts transfers them to another machine, your DR machine. And then on this machine here, there's a process running or script running that will automatically roll forward all the changes to your target database. So essentially giving you like a warm spare to use in case of a failure with a main machine. So the problem with AI replication, you still need, it requires a lot of complex scripting. There's always minor adjustments and manual intervention. If there's a problem with a transfer, you have to get in there and troubleshoot it. You still need a progress license on the target server, and often it's more expensive than getting an OpenEdge replication license. So OpenEdge replication helps you in recovering from a disaster. So basically, it replicates from one server to another server, and I'll show you that in a second. What's great about it is that you could make use of your target database for reporting, and it's also if it's set up right, it's also low latency. So this is the OpenEdge replication architecture. So on your primary machine, you have your database here, users doing their day-to-day stuff, causing trouble for you guys. and writing to the AI extents. So there's a process here called a replication server and an agent that reads the AI extents, transfers all the AI nodes to the replication agent on a target machine, rolls them forward on the target database. So what's cool about this is that you can make use of your target database. It doesn't just sit idle waiting to be used in the event of a failure. This is with OpenEdge Replication Plus, by the way, not the standard OpenEdge replication. Another obsolete best practice. So overemphasizing on the fixed extents. So making sure, putting extra effort, always making sure you never get out of your fixed extents. And the main reason for that is because writing into the variable extent there's an IO penalty. But since then, I mean, these subsystems are a lot faster than they were a long time ago. So the performance penalty on writing to the variable extent, it's usually pretty negligible. So let me give you an example. So on a picture Monday to Friday, 9 to 5 shop, growing their database about 1 gig per month. So on a standard 4K database with 512 blocks per cluster, so every extension, every time it needs to extend, it's about 2 megs. So 1 gig per month divided by those 2 megs is 500 extensions. 500 extensions divided by 20 working days is 25 extensions per day divided by 8 hours. So we're talking about 3 extensions per hour. So what does that mean? So every 20 minutes, your users are going to have to wait a few milliseconds for your database to grow. All right. Absolute best practice number 6. So maintaining database extents less than 2 gigs. So this is an actual database of a DBA that was absolutely adamant about making sure you're in 2 gig extents. So who can guess how many extents this reached? So 100, 200, 216 extents. So, and, there was a valid reason once upon a time for doing this. They used to make really big hard drives with little small capacity. We didn't have the large files option either on the Progress side or the Unix side. And there were some problems with some of the older Unix versions with triple inode indirections. Also used as a way to prevent extents from filling up the file system. And kind of a crude way of making sure you're always stuck in your fixed extent, that you'll never go into your variable extent. So no longer a good idea for a while now, actually. Also, 2 gig fixed extents requires more file handlers, descriptors. It's a lot harder to manage. You saw before by following this practice, we ended up with more than 200 extents. And also the database will crash anytime a file reaches more than 2 gigs. So you want to get beyond that 2 gig limitation. So enable large files. So when the database is down, run this command. Very simple. It's yeah. I'm sorry?
You must have an enterprise license. Workgroup still doesn't have a right now.
Workgroup cannot go beyond 2 gigs. Is that true? Yes. Okay. So enterprise workgroup, you're pretty much stuck using. Yeah. So you have to enable it at the progress level, but you also have to make sure you enable it at the file system level. Make sure your operating system is able to grow beyond the 2 gigs. And also for Unix, make sure your U limit is high enough so you're able to read that file. Another absolute best practice, using SQL width, regularly adjusting your SQL width. So who uses SQL? All right, quite a few of you. So I'm sure you run into this problem where you have users trying to query a record, and then you get a message saying it's exceeded its max length. So to get around that, you have to find the table number and then run dbtool or run dbtool regularly to extend that SQL width. So new in version 11.6, you have something called autonomous schema update. And what this does, it automatically extends your SQL width, so you don't have to keep running that every so often. So basically as simple as adding this to your database startup parameters. Obsolete practice number 8. So absolute practice number 8. So we could do a lot of the stuff online. So if you're doing some of these offline, so you have the option to do these online with some limitations, of course. So you can modify the schema, add new tables, new fields and stuff like that. You can add database extension storage areas, modify your database parameters. And I know in version 10 you have more stuff you can do online. In version 12. But these are stuff you can do from 10 and up. So other absolute practices, there's actually a command to truncate your log file. So you don't have to use a redirection to your log file. You can use there's a command called prolog. Also, try and avoid using protocols that transmit your data in clear text. So like FTP and Telnet and stuff like that. So try and use the encrypted versions of these, like SSH, SFTP, etc. Because your data can be sniffed by sniffer tools. So good idea to use that. So what will the future look like? Who knows? But so what we've seen. So what has been useful for many years, not necessarily the best thing to do today. There's always better ways to do it with the newer versions. So when you upgrade to a new version, it's a good idea to go back. So not only making sure your environment and your programs are working correctly, but also review your DBA practices and make sure that you're still doing things the most efficient way possible. And that's it. On the database log.
On the DB log,
Oh,
yeah.
yeah, that's interesting. I didn't know that. Good observation. So 11.7, you could set up auto log truncate on your database. Thank you.
Similar to what's available already in the app.
All right, any other questions? All right, if you do have any questions, feel free to email me. We're always open to questions. Ask me what the weather is like, whatever. All right, thank you very much.